Okay, let's discuss question number 4. We are given this function ln x over x for domain between 1 until exponent. Find the area of the region bounded by the fx and the x-axis. So clearly in this case, you cannot sketch the graph because we never learned how to sketch the combination of a ln and reciprocal function. Okay, so this question give you the domain 1 until e. So this can be your lower limit and upper limit. Okay, and then since we only have one function, so you don't have to worry about first function minus second function or the otherwise. Okay, so we only have one function, so it is safe to just write the area as integral from 1 until e, and then write down the function ln x over x dx. Okay, so here we are choosing with respect to x because we want to find the region that is bounded by the curve and the x-axis, and the limit is also given in terms of x, so it is very suitable to find the area with respect to x. Okay, so that is the first step. The second one, we have this function ln x over x. Okay, so remember I said before that we need to look at the hierarchy. First, we need to look whether we can direct integrate or not. So clearly in this case, we cannot direct integrate, okay, because we have ln x and then there's over x. Okay, and you can see that actually here in this case we have ln x and 1 over x. Okay, maybe some of you will straight away go to IBP, but wait, look first if you can use IBS, because you can see that if I let this as u, the integral, the derivative will be 1 over x, right? So it is here. So before you go to IBP, you can look that these two can be u and du dx. Okay, so it's very important for you to check first before straight away go to IBP. So we will use integration by substitution in this case. So we will let u equals to ln x du dx. The derivative will be 1 over x. Okay, so we can take du as 1 over x dx. Okay, so this I can write it as 1 until e ln x dot 1 over x dx. Okay, kalau tak tulis macam ni pun it's okay, but I want to give a clear explanation, okay, so that you can understand. You can skip this part actually. Okay, so now in this question I want to show how to find the integration by substitution, how to use the IBS technique without changing the limit. Okay, so let's substitute. Ln x is equal to u, 1 over x dx is equal to du. Okay, so we reach the purpose of IBS where we are actually simplifying the original integral into a simpler one, a very simple one. Okay, so in this case when you substitute the u, okay, we don't have to write the limit yet, okay, because the limit is actually for x value. We didn't change the limit as in the previous question. Okay, so I will calculate without the limit, integrate this, okay, and then now I will substitute the limit, but I need to substitute what is u. So in this case u is equal to ln x, so let me rewrite this as ln x over 2. Okay, since we are now writing in terms of x, I can substitute the limit 1 until e again. Okay, so I hope you don't get confused on how to write the limit, how to neglect the limit first when you have u. Okay, and then we just calculate or substitute the limit. Okay, okay, so ln e squared is 1, okay, and then over 2, ln 1 is equal to 0, so 0 over 2 is still 0, hence the answer is 1 over 2 units squared. Okay, so this is for part A of the question, and then for part B, hence find the volume of the solid generated by revolving the region 2 pi radian about the x-axis. Give your answer in terms of e and pi. Okay, so we need to find the volume. Actually, the word hence over here apply to the same limit and the same function with respect to x. Okay, the only difference is that we need to use the correct formula of volume, okay, which is pi dx, and then we need to square the function. Okay, so here I have ln x over x squared. Okay, so in this case we cannot use integration by substitution method because we have squared over here. Okay, so we can go to the next hierarchy, which is the integration by part. Of course, integration by partial fraction tak sesuai lah, sebab ini bukan dalam bentuk polynomial yang ada fraction tu. Okay, so we don't go to integration by partial fraction. Okay, so now I will show you that you can have two functions over here. The first one is ln x squared, and the second one is 1 over x squared. Okay, so we have these two functions, and we need to refer to this acronym. Okay, starting with u until dv. Okay, the higher hierarchy is the polynomial over here, so this will be our u, and we have a reciprocal somewhere below the trigo, so this will be dv. Okay, so let's calculate the corresponding pair. Okay, if I have u equals to ln x squared, then du dx is equal to 2 ln x 1 of x. Okay, 2 bawa depan, salin balik, ni jadi kuasa 1, and then we differentiate anything inside the bracket. Okay, so let me rewrite this. Okay, du is equal to 2 ln x over x dx. Okay, so this is the first one, and then we have dv equal to 1 over x squared. Okay, because 1 squared x squared, so 1 squared is equal to 1, and then we will integrate this. Okay, so we have v equal to integral of x negative 2 v equal to x negative 1 over negative 1, which is negative 1 over x. Okay, so now we already have u, du, v, and dv. Okay, so let us use the integration by part formula. U dv equals to uv minus v du. Okay, so again let me rewrite the volume. Okay, so the first part is here for this, and this is equivalent to uv. So uv minus integral. Okay, so yang ni kira dah settle lah, so we just put the limit 1 until e. Okay, and then v du, so v is negative 1 over x, and then du is 2 ln x over x dx. Okay, so we can simplify. Okay, so after simplifying, we can see that again we need to integrate this by part. Okay, so we have to identify the u and dv once again. Okay, so u is equal to ln x, dv is equal to 1 over x squared dx. Okay, so du dx is equal to 1 over x, du is equal to 1 over x dx. Then integrate both sides, can have v equal to integral of x negative 2 dx, which is x negative 1 over negative 1, which is negative 1 over x again. Okay, so I will substitute into this formula. Okay, so the first part over here we just copy together with number 2. Okay, so let me copy. Okay, and now this part over here we can apply the integration by part formula. Okay, so uv, first we need to have uv, so ln x. Okay, this is for 1 until e, and then minus v du. Okay, so v is equal to negative 1 over x, and du is 1 over x dx. Okay, close bracket. Okay, so now we can simplify this part. The limit is from 1 until e, and then this become plus 1 over x squared, right? Okay. So now we can substitute the limit and integrate this part. Okay. Or maybe we can expand first with 2 and then integrate. Up to you. This should be minus, right? So I have minus 2. Then this become plus. Integrate this. We will have x negative 1 over negative 1 from 1 until e. Okay, so the limit are all the same, meaning that we can combine this expression so that it looks simpler. Okay, so I have over here negative ln x over x, okay, ln x squared over x, and then minus 2 ln x over x, and then minus 1 over x. Everything has limit 1 until e. Okay, so next step is to substitute the limit. Okay, so we can see that ln e, if we square, we get 1. So I have negative 1 over e minus 2 over e. Okay, this become 1. Then minus 1 over e. And then plus, ln 1 is 0. So this is 0, 0. So I will have 1 over 1. Okay. Sorry, I have number 2 actually over here. Oh, I forgot to multiply 2. 2 must be multiplied here and here. So I must add number 2 in front here. So this should be 2. calculating this, you can have the answer. And I forgot one important thing. Okay, sorry about that. Just notice we have pi because this is volume. Oh, I will get 0 mark if I do this in Excel. So I need to write pi in front of each my calculation. If not, I will get 0. Pi. So pi. So the answer should be in terms of pi. And simplifying this, you'll get negative 5 over e. So I put 2 in front minus 5 over e units cube. So this is the volume. Okay.